Hello there, and welcome to the Sleepy Space Channel. The edge of the universe is not where the universe ends, and that is only the first strange thing about it. Follow any direction far enough, and the darkness gives way to a wall of ancient light, the oldest light in existence, arriving from every side at once. Out there, space itself carries whole galaxies away faster than light, and every observer stands at the center of their own universe, wrapped in a horizon that belongs to them alone. Tonight we trace what the edge is made of, why it is a time rather than a place, and what may lie beyond it. If you find these slow explorations of the cosmos worth your time, a like or a subscribe helps the channel reach others who do. Thank you for being here. But for the next 2 hours, none of this is anything you need to carry. The edge lies farther away than any worry can travel. Settle in. Let your shoulders soften. Let your breathing slow. Let the day fade away. Let's begin. There is a strange and quietly unsettling fact hiding in the most ordinary view a human being can have. Step outside on a clear night, far from city light, and look up between the stars. What you find there is blackness. It looks like emptiness, like the absence of everything, like the end of the world hanging overhead. And for most of human history, that is exactly what people believed it was. The dark between the stars seemed to be nothing at all, a void without content, a silence without depth. But that blackness is not what it appears to be. It is not empty, and it is not dark. It is full of light that your eyes were never built to see. The blackness overhead is an edge, but it is not the edge of the universe. It is the edge of your own perception, drawn across the sky, and beyond it the universe simply continues, unseen. Tonight we are going to travel out to that edge, slowly, and discover what actually waits there. The answer is stranger than darkness. The answer, as we will find, is the oldest light in existence, arriving from every direction at once. The darkness itself is the first clue, and it is worth sitting with for a moment. We are often told that the universe is endless, a sea of stars and galaxies extending outward in every direction without limit. But if that were the whole story, the night sky could not look the way it does. Imagine a universe that is infinite, eternal, and filled evenly with stars that have always been shining. In such a universe, every line of sight would matter. Draw a straight line from your eye out into the sky, in any direction you like, and extend it far enough. Sooner or later, that line would strike the surface of a star. A nearby star, perhaps, or one at an enormous distance, but eventually a star. And if every line of sight ends on a star, then every point of the sky should glow. The whole dome of night should blaze like the surface of the sun, with no gaps, no darkness, no rest. Night, in the deepest sense, should not exist. And yet night exists. The sky between the stars is dark, and that simple, homely observation carries a sobering weight. It tells us that the picture of an eternal, unchanging, endlessly star-filled universe cannot be right. Something about it has to give. Either the universe has not been shining forever, or the light from its farthest reaches cannot arrive in a form we can see, or both. The darkness of the night sky is not a small fact. It is one of the oldest and most powerful observations in all of astronomy, available to anyone with clear weather and patience, and it quietly rules out an entire idea of the cosmos. The dark is not a backdrop. The dark is evidence. The resolution comes in 2 parts, and both of them will matter for the rest of tonight's journey. The first part is that the universe has an age. It has not been here forever. There was a beginning, and only a finite stretch of time has passed since then. Light is fast, faster than anything else that exists, but it is not infinitely fast. It takes time to cross distance, and it has only had so much time to work with. That means there are regions of the universe so far away that their light has not yet completed the journey to your eyes. Their stars may be shining at this very moment, pouring light outward in every direction, and none of it has arrived here yet. When you look at the dark between the stars, part of what you are seeing is simply light that is still on its way. The sky is dark, in part because the universe is young enough that most of its light has not reached us. The second part of the answer is subtler, and it opens the door to everything that follows. The universe is expanding. The distances between galaxies are growing, and they have been growing since the beginning. As light travels across that growing distance, something happens to it. The light itself is stretched. Its waves are pulled longer and longer, the way a pattern drawn on soft material stretches when the material is pulled. Visible light, stretched far enough, stops being visible. It slides down out of the colors your eyes can register into gentler and longer waves, first into the infrared, and then further still. The light from the most distant regions of the universe has been stretched so much on its long journey that by the time it arrives, no human eye can register it at all. It falls on your face on a clear night, and you feel nothing, and you see nothing. But it is there. So the blackness between the stars is not an absence. It is a presence your senses cannot detect. The night sky is actually glowing, everywhere, in every gap between every star, with light that has been traveling for almost the entire history of the universe. What looks like a void is a limitation of the instrument you were born with. Human eyes are small, and they evolved for daylight on one small world, for ripe fruit and moving water, and the faces of other people. They register a thin slice of the full range of light, a narrow band of waves, and everything outside that band simply does not exist for them. The universe does not end where our seeing ends. It keeps going, bright in ways we cannot perceive, and the darkness we see is the boundary line between what our eyes can catch and what they must let pass. You can feel how strange this is if you hold both truths at once. The sky above your house, tonight, is completely full. There is no direction you can face that is not receiving light from the deep universe. The gaps between the stars are not gaps at all. They are windows onto something older than every star you can see, and the only reason they look black is that the light coming through them has grown too long, too stretched, too old for your eyes. In a very real sense, no one has ever seen the night sky. We have only ever seen the part of it our bodies allow, a bright scattering of nearby stars laid over a glowing depth we are blind to. This is the meaning of the edge we will keep returning to tonight. There is a boundary out there, a limit to what can be seen, and it is real. But it is not a wall at the end of space. It is a horizon, and a horizon is a different kind of thing. When you stand on a shoreline and look out to sea, the water seems to end at a clean line in the distance. Nothing about the ocean stops at that line. The line belongs to you, not to the sea. It is drawn by the height of your own eyes and the curve of the world, and if you walk along the beach, the line walks with you. Every observer standing on every shore has their own horizon, each one centered exactly on themselves. The ocean does not care where any of those lines fall. It continues beneath all of them, indifferent, enormous, and mostly out of sight. The edge of the visible universe works the same way. It is a line drawn by the age of the cosmos and the speed of light, and it is centered, perfectly, on you. It is not the place where the universe ends. It is the place where your view ends. And just as a sailor can never sail to the horizon, because the horizon retreats as they advance, no traveler could ever reach the edge of the observable universe. Arrive at any point along it, and you would find ordinary space, ordinary galaxies, an ordinary sky, and a new horizon drawn around you at the same enormous distance. The edge moves because the edge was never a place. It was always a relationship between an observer and the light that has had time to reach them. Hold that thought gently, because everything strange that follows tonight grows out of it. We live inside a sphere of visibility, a bubble of everything whose light has had time to arrive, and beyond that bubble the universe continues without any obvious limit. The bubble has a size, and the size can be measured. It has contents, and the contents can be counted, at least roughly. It has an edge, and the edge, when we finally learn to see it properly, turns out not to be darkness at all. Out at the very limit of everything, in every direction, there is a wall of ancient light, the first light that ever moved freely through space, still arriving after almost 14 billion years of travel. We cannot see it with our eyes. For most of history, we could not see it with anything. But it is there tonight, passing through the dark above your roof, through the branches of trees, through the quiet air of the room where you are resting. So let the blackness of the night sky settle into a new shape in your mind as we begin. It is not the void it pretends to be. It is a horizon, drawn kindly around you, holding everything you could ever see within it. Beyond it, more universe. Within it, more light than your eyes will ever know. The darkness is not the end of anything. It is only where our seeing rests, and beyond our seeing, the universe carries on, patient and unhurried, exactly as it has always done. In the parts of this journey still to come, we will measure the bubble, walk backward through time along beams of old light, find the wall of first light at the edge, and learn why the numbers written on that wall seem, at first, to be impossible. There is no rush to get there. The edge has been waiting for almost 14 billion years. It can wait a little longer while you settle in and let the night hold still around you. The region of the universe we can actually see has a name, and it has a shape. Astronomers call it the observable universe, and its shape is a sphere, a perfect ball of visibility with a single point at its center. That point is you. The observable universe is defined as everything whose light has had time to reach us since the beginning of time itself, and because light spreads at the same speed in every direction, the region it defines is the same in every direction. Look left, look right, look up through the ceiling toward the stars, and the distance to the limit of seeing is identical every way you turn. We live at the middle of a bubble of light, and everything humanity has ever observed, in the entire history of looking, has been inside it. The bubble is large in a way that resists imagination, but the numbers themselves are simple to say. From where you are lying now to the edge of the observable universe is about 46.5 billion light-years, and that distance extends outward in every direction. Measured across, from one side to the other, the bubble spans about 93 billion light-years. Everything we have ever known sits inside that span. Every star ever named, every galaxy ever photographed, every point of light ever caught by any telescope, on any mountain or in any orbit, all of it lives inside this one sphere of seeing, with us resting quietly at the center. A light year, it is worth pausing to say clearly, is a distance, not a time. It is the distance light travels in a single year. Light moves through space at the fastest speed the universe permits, fast enough to circle the Earth 7.5 times in a single second, fast enough to cross the distance to the Moon in little more than a second. Nothing that carries matter or information moves through space faster. This is not a technological limit waiting for better engines. It is a ground rule of the universe, woven into the structure of space and time themselves. Because that speed is fixed and universal, distance and travel time become two ways of saying the same thing, and astronomers measure the deep universe in the time its light needs to make the journey. A star 4 light-years away is a star whose light spends 4 years reaching us. The edge of the bubble, 46.5 billion light-years away, is the place whose light has only just now completed the trip. The contents of the bubble are worth lingering over, slowly, the way you might walk through a large, quiet house at night. Inside the observable universe there are, by current estimates, something like 2 trillion galaxies. 2 trillion separate cities of stars. Each of those galaxies holds its own population, ranging from a few million stars in the small ones to many hundreds of billions in the great ones. Multiplied together, the stars inside our bubble number in the billions of trillions, a figure so far beyond counting that it stops behaving like a number and becomes something closer to a texture. And around and between those stars there are planets, moons, drifting clouds of gas and dust, rivers of invisible matter whose gravity shapes the whole arrangement, and light, everywhere light, crossing the emptiness in every direction at once. All of it inside the bubble. All of it, in principle, visible from where you rest. The galaxies are not scattered through the bubble at random either, and the arrangement they keep is one of the quiet wonders of the deep sky. Mapped across billions of light-years, the galaxies gather along enormous filaments and sheets, strands of light millions of galaxies long, woven around great rounded hollows where almost nothing shines at all. Astronomers call the hollows voids, and some of them span hundreds of millions of light-years of nearly perfect emptiness, regions so sparse that a traveler placed at the center of one would need a telescope to see any galaxy anywhere. The filaments meet at dense knots, where thousands of galaxies crowd together into clusters, orbiting one another over billions of years. Seen all at once, the pattern resembles a foam or a net, or the structure of something grown rather than built, threads of light around cells of darkness, repeating in every direction for as far as our instruments can reach. Our own galaxy rides one modest strand of this structure, partway along a thread, in the quiet outskirts of the pattern, which is to say, in an entirely ordinary place. And the pattern itself, remember, fills the bubble evenly. There is no thinning toward the rim, no ragged frontier where the weave runs out. The observable universe is upholstered in galaxies from the center to the edge of seeing, and beyond the edge, by every indication, the weave simply continues, unobserved and unbothered. And here is the first genuinely strange thing about the edge of the universe, the first of many we will meet tonight. The bubble is centered on you, but there is nothing special about you. The center is not a throne. It is an accident of geometry, and everyone has it. The observable universe is defined by where light has had time to arrive, and light arrives somewhere different for every observer. A person on the other side of the Earth has a bubble almost identical to yours, shifted by the width of a planet. An astronomer on a world circling a star on the far side of our galaxy has a bubble shifted by 100,000 light-years, containing almost everything yours contains, plus a sliver of universe you will never see, minus a sliver that only you can. And a being in a galaxy 10 billion light-years away has a bubble centered on themselves, reaching 46.5 billion light-years in every direction from where they stand, deep into regions that are permanently beyond our view. There are, in other words, as many observable universes as there are places to stand. The universe itself does not come with a center marked on it. Every point in it is the middle of somebody's sky. This is not a poetic flourish. It is a plain consequence of how light and time work, and it quietly dissolves one of the oldest human assumptions, the idea that there is one true view of the cosmos, one master map with a single edge drawn on it. There is no such map. There is only an endless family of overlapping spheres, each one centered on an observer, each one containing a different but overlapping portion of the whole. Your bubble is yours alone. No one else in the universe sees exactly the sky you see. You can feel the strangeness of this by imagining a simple journey. Suppose you could travel, instantly, to a galaxy sitting at the very limit of your view, out at the edge of your bubble, 46.5 billion light-years from this room. You might expect to arrive at the frontier of everything, some thinning border district of the cosmos where the galaxies run out and the darkness begins. But that is not what you would find. You would find yourself in an ordinary galaxy, among ordinary stars, under an ordinary sky. And when you looked around, you would find a new observable universe stretched around you, the same size as the old one, reaching 46.5 billion light-years in every direction from your new position. Half of it would contain regions you could never have seen from Earth. And somewhere out near the limit of your new sky, at the very edge of your new bubble, would sit the small, distant patch of universe where you began, our own galaxy, hanging near someone else's horizon the way theirs once hung near ours. The edge, in other words, refuses to be approached. It moves with you because it belongs to you. It is drawn around the observer the way a horizon is drawn around a ship, and no amount of sailing brings the ship closer to that line. This is the sense in which the observable universe is a perspective rather than a place. It is not a container with walls. It is a view, an enormous spherical view, and like every view it has a viewer at its center and a limit at its rim, and the limit exists only because the view does. None of this makes the bubble less real. Its edge is not imaginary. Light truly has had only so much time to travel, and there truly are regions whose light has not arrived and may never arrive. The sphere of visibility is as real as anything in science, measured and mapped with extraordinary care. What the bubble is not is the universe. The universe is the whole thing, the entire fabric of space and matter and light, and by every indication it extends far beyond the edge of what we can see, perhaps without any end at all. We will come to what might lie beyond in the later parts of tonight's journey. For now, it is enough to hold the distinction gently. The observable universe is what the age of the cosmos and the speed of light allow us to know. The universe itself is under no such restriction. There is a comfort in this arrangement if you let it settle. The bubble is not a cage. Nothing about it confines you, any more than the horizon at sea confines a swimmer. It is, instead, a kind of enormous inheritance. Within your personal sphere of seeing sit 2 trillion galaxies, arranged in sheets and filaments and slow drifting clusters, every one of them delivering its light to the exact place where you are resting tonight. The night sky is addressed to you. Not because the universe singles you out, but because geometry does, freely, and it makes the same gift to every observer everywhere. Each point in the cosmos receives its own complete sphere of ancient light, its own private edge, its own centered sky. So we have the bubble now, measured and in hand. 46.5 billion light-years to the rim, in every direction. 93 billion light-years across. 2 trillion galaxies inside. One observer at the center, which is to say, you. What we do not yet have is an understanding of what the rim actually is, and why it sits at that particular distance, and what a traveler would see there. To get to those answers, we need to notice something odd about the light that fills the bubble, something we have been stepping around politely until now. The light in the deep universe is old. All of it. And the deeper we look, the older it gets. Looking outward, it turns out, is not really looking across space at all. It is looking backward, down the long corridor of time, toward the beginning of everything. That is where we will drift next, unhurried, with the whole night still ahead of us. Every act of looking is an act of waiting, though we almost never notice. Light is quick, but it is not instant, and everything you have ever seen reached you a little late. The lamp across the room is a few billionths of a second in your past. The far side of the street is older still, by an amount too small to matter. In daily life, the delays are so tiny that the world feels simultaneous, a single shared moment spread across everything you can see. But the feeling is an illusion of short distances. Stretch the distances out, and the delay begins to open like a seam. Look at the moon, and you are seeing it as it was about a second and a quarter ago. Look at the sun, and the light warming your face left its surface a little over 8 minutes in the past. If the sun were to change in some deep way at this exact moment, the sky would keep its secret for those 8 quiet minutes, and no instrument on Earth could know any sooner. Move outward, and the seam widens into a canyon. The nearest star beyond the sun sends us light that is more than 4 years old. The bright stars of the familiar constellations are decades, centuries, sometimes thousands of years in the past. There are stars visible on a dark night, whose light began traveling before anyone now alive was born, before the cities we live in existed, before the languages we speak had formed. The sky you see tonight is not a picture of the universe as it is. It is a collage of moments, each one mailed from a different point in history, all arriving together and pretending to be a single scene. Nothing in the night sky is happening now. The sky is a stack of postcards, each posted at a different time, each carrying an image of a moment that has already gone. With galaxies, the delays grow so large that they stop being delays and become eras. The nearest great galaxy to our own sends us light that is about 2.5 million years old. When that light began its journey, our ancestors were only beginning to shape stone tools, and no human eye existed in its modern form to receive it. We see that galaxy tonight, as it was in that distant age, a portrait delivered across an ocean of time. Whatever it looks like at this moment, however its spiral arms have turned, whatever new stars have kindled in it, none of that information has reached us, and none of it will for millions of years to come. And that galaxy is our close neighbor. It sits by cosmic standards, just across the street. The delays carry one consequence that people often find strange the first time they meet it, and it is worth meeting gently. Some of the stars visible tonight may no longer exist. A star, thousands of light years away, could have ended its life centuries ago, collapsing or scattering itself into the dark, and we would have no way of knowing. Its final light is still in transit, still crossing the long distance, and until that last shipment arrives, the star shines on in our sky, present in every way that seeing can measure, absent in every way that matters to the star. Astronomers have watched this play out in reverse as well. When a star explodes in a distant galaxy, the light of the explosion arrives tonight from an event that concluded millions of years ago, a piece of ancient news delivered fresh. There are even cases where the same explosion has been seen more than once, its light bent along different paths around an intervening cluster of galaxies, some paths longer than others, so that the same moment of the same star's ending arrived in our telescopes in separate showings, years apart. The universe does not merely deliver the past. Sometimes it delivers the past in installments, the same scene repeated, as if to be sure we saw. The deeper the view, the older the image, and there is no exception and no way around it. Telescopes that photograph galaxies a billion light-years away are photographing a universe a billion years younger than tonight. The great deep-field images, those long, patient exposures where thousands of galaxies crowd a patch of sky smaller than a grain of sand held at arm's length, are not maps of distant space so much as core samples of time. Near the front of the sample, galaxies as they were in recent cosmic history. Farther in, galaxies from the universe's middle age, their shapes subtly different, their colors shifted. Deeper still, small, bright, chaotic things from the early ages of the cosmos, galaxies caught in the act of assembling themselves. A single photograph can hold 10 billion years of history in one frame, every layer present at once, like the rings of an enormous tree cut through by a single view. The most distant galaxies ever imaged appear as they were when the universe was only a few 100 million years old. We see them in their infancy, small and fierce and newly lit, some of the first structures that ever formed. And here is a thought worth holding softly, because it changes the meaning of every deep photograph you have ever seen. Those galaxies are not like that anymore. Wherever they are now, they have had nearly the entire age of the universe to grow, to collide and merge with their neighbors, to settle into calm middle age. Some of them today may be enormous, quiet, golden galaxies, their wild youth long behind them. Others may have been absorbed entirely into larger systems and no longer exist as separate things at all. The infant we photograph has, in the time the photograph took to arrive, lived almost the whole of cosmic history. We are seeing baby pictures of galaxies that are now old, and we will never see their adulthood, because that light is still crossing the enormous distance between us, and most of it has barely begun the trip. You might wonder whether there is some way to peek around the delay, to find out what a distant galaxy is doing right now. There is not, and the reason runs deeper than a limit of engineering. Light is the fastest messenger the universe permits. No signal of any kind moves through space faster. That means the present moment of a distant place is unobservable in principle, not merely in practice. There is no possible instrument, no conceivable technology that could show you a distant galaxy as it is tonight. Its now is sealed away from your now by the very structure of the universe, and the only thing that can ever arrive is the past, carried patiently at the speed of light. In a deep sense, the phrase, "right now," does not even stretch cleanly across those distances. Each place keeps its own present, and the presents are joined only by light, and light takes its time. Rather than a frustration, you can hear this as something gentler. It means the universe carries its own memory. Nothing that shines is ever really lost, because its light keeps traveling, outward, in every direction, carrying the image of what was. Somewhere in the universe tonight, the light of the sun as it was 1,000 years ago is still spreading, still legible, still carrying the picture of a star that our ancestors saw. Any observer at the right distance, looking our way with good enough instruments, would see the Earth of 1,000 years ago, or 10,000, or 1,000,000, depending on where they stand. The past is not gone. It is in transit. The universe is a library where every book is still being delivered, and every reader, everywhere, receives a different volume of the same immense story, depending on how far away they sit. And this, finally, is the key that unlocks the edge of the universe, the idea the whole night has been leaning toward. If looking farther always means looking earlier, then there is a natural end to how far any telescope can ever look. Follow the logic gently outward. At 1 billion light-years, we see a universe 1 billion years younger. At 10 billion light-years, we see galaxies in their first youth. Push farther, and we reach distances where the light left before the first galaxies had formed, and what we see is the raw material of the universe, clouds of matter only beginning to gather. Push farther still, and we arrive at light from an age before the first stars, when the cosmos held no lights at all. Keep going, and somewhere out there, the looking must reach the beginning itself, the earliest moment from which light could ever have been sent. Beyond that, there is nothing further to see, not because space ends, but because time does. The ultimate limit of vision is not a wall in space. It is the first page of history. That is what the edge of the observable universe actually is. It is the place in the sky where looking out has finally looked all the way back. The rim of our bubble, that sphere, 46.5 billion light-years away in every direction, is not a boundary of the cosmos. It is the image of the universe's earliest visible moment, wrapped around us like the inside of a globe, the deepest layer of the deepest photograph that could ever be taken. Every direction ends in the same era, because every direction, followed far enough, arrives at the same beginning. The edge of seeing is made of time, and it surrounds us because the past surrounds us. Wherever we look toward the beginning, and the beginning answers from every side at once. What remains is to actually see it, and there the story takes its strangest turn so far, because the light from that first age still exists, and it is still arriving, and it turns out that human beings found it, without at first knowing what they had found. The light at the edge is not visible, not even to our greatest telescopes that gather ordinary light. It has been stretched too long, aged too far, cooled too much on its 14 billion-year journey. To find it, astronomy had to learn to see in an entirely different register, below the deepest red the eye can imagine. That descent, down through the long wavelengths, from the colors of the rainbow into the invisible country beneath them, is the next stage of our drift outward. It asks nothing of you but stillness. The old light will do all the traveling, as it always has. Light behaves as a wave, and that single fact carries most of tonight's remaining story. A wave is a repeating pattern in motion, a procession of crests and troughs, and the distance between one crest and the next is called the wavelength. For light, wavelength is everything. It decides the color. The shortest waves the eye can catch look violet and blue. Middle lengths look green and yellow. The longest visible waves look red. And on either side of that narrow band, the waves keep going, shorter than violet and longer than red, carrying energy through the universe in forms no eye was ever built to register. The rainbow, it turns out, is a small lit window in a very long corridor, and most of the light in the universe passes by outside the glass. To understand what happens to light on a long journey through an expanding universe, picture a pond on a still day. A stone drops into the water, and around the point of impact, the surface rises and falls in tight, clearly defined rings. Near the center, the waves are crisp. Their crests sit close together, and their motion is easy to see. But watch the rings as they travel outward. With distance, they widen. The crests spread apart, the peaks flatten and grow gentle, and the pattern softens as it goes, until far from the impact, the waves become too broad and too low for the eye to pick out at all. The surface looks calm again. Yet the wave has not stopped existing. It has only stretched past the threshold of your perception. The energy of the stone is still out there, moving through the water, and an instrument sensitive enough could follow it all the way to the far shore, reading the arrival of ripples the eye gave up on long ago. Light crossing the universe lives the same story. As it travels, the space it is traveling through is expanding, and the wave stretches with the space that carries it. Every year of the journey, the distance between one crest and the next grows a little. Light that set out as visible color does not stay visible. Given enough distance and enough time, blue light stretches toward red. Red light stretches past red, out of the window of vision entirely, into the region called the infrared, where the waves are longer than the deepest color the eye can name. Stretched further still, the waves grow longer than infrared, entering the territory of microwaves, waves measured not in millionths of a millimeter, but in actual millimeters, broad and slow and utterly invisible. Astronomers call this stretching the redshift, because visible light drifts toward the red end of the rainbow as it lengthens. The farther away a light source sits, the more expansion its light has crossed, and the more its waves have grown by the time they arrive. Distance, in an expanding universe, is written into the light itself. This is why the deep sky is black to human eyes, and it is worth saying plainly now that we can. The light of the most distant regions of the universe is arriving all the time. but it arrives stretched out of the visible band. The pond has carried the ripples too far. What reaches us is real light, carrying real images of real places, but its waves have grown too long for the small instruments in our faces. The darkness between the stars, which we met at the beginning of tonight's journey, is exactly the calm-looking water far from the splash. The pattern is still there. We simply cannot see waves that broad, and so we call it black, and for thousands of years we mistook the limits of our eyes for the limits of the world. The way past that limit is to build better eyes, and that is precisely what astronomy has done. Instruments can be made that register the long waves directly, reading the infrared the way our eyes read color. Some of this technology is familiar and close to home. Night vision equipment senses the shallow end of the infrared, the warmth radiating from bodies and engines, and turns it into a picture. But that only skims the surface of the invisible country. To catch the deeply stretched light of the early universe, astronomers built a great infrared observatory and sent it far from Earth, where it drifts in the cold and the dark, shaded from the sun, its enormous golden mirror held at temperatures colder than any winter this world has ever had. It needs that cold because warmth is exactly what it is trying to see, and an instrument that glowed with its own heat would be blinded by itself, like trying to hear a whisper while humming. It helps, at this point in the journey, to see the whole corridor of light laid out at once, because the visible rainbow occupies so small a stretch of it. On the short side of violet lies the ultraviolet, the energetic light of the hottest young stars. Shorter still come the piercing rays that only the most violent objects in the universe produce, the light of matter falling toward collapsed stars and the flashes of distant catastrophes. On the long side of red, the corridor runs the other way, into the infrared, where cool stars, warm dust, and stretched galaxy light live. Beyond the infrared come the microwaves, and beyond the microwaves the radio waves, the longest light there is, with single waves that can measure meters or kilometers from crest to crest. Every region of this corridor carries its own portion of the universe's story, and almost none of it reaches the ground, because the atmosphere that keeps us alive also shutters most of the windows. So astronomy, over the generations, has climbed above the air with one instrument after another, each built for a different region of the corridor, each opening a window onto a sky no eye had ever seen. The universe, as we now know it, was assembled from all of those skies together, layer laid upon layer, and the deepest layer of all, the one waiting at the bottom of the longest wavelengths, is the one our journey is approaching now. What that observatory sees is a different sky. Where our eyes find blackness, it finds galaxies. It looks into the gaps between the stars and reads the stretched light waiting there, image after image, deeper and deeper, galaxies whose light has traveled for 5 billion years, for 10 billion, for more than 13 billion. It can see almost to the era of the very first starlight, catching small young galaxies whose glow has been stretched 12, 15, 20 times longer than when it left them. Their light departed as the fierce blue and ultraviolet shine of newborn stars, and it arrives as a faint infrared murmur, and the great cold mirror gathers it patiently, hour after hour, until the picture forms. Through instruments like this, the blackness of space has been shown, over and over, to be an archive rather than an emptiness. Almost everything that has ever happened inside our bubble of visibility is still visible, somewhere down the long wavelengths, to an eye good enough to read it. Almost everything. Because even the greatest infrared eye does not reach the edge. Beyond the most distant galaxy it can photograph, the darkness resumes, and this time the darkness is honest. Past a certain depth, there are no more galaxies to see, no stars, no lights of any kind, because we are looking into the age before lights existed. The universe in its first few 100 million years had no stars yet, only darkness and drifting matter, a cosmos still setting its table. From that era there is simply no starlight to receive, however sensitive the mirror. Astronomers sometimes call it the dark ages of the universe, the long, dim stretch between the beginning and the first dawn. The deepest galaxy photographs press right up against it, and there the photographs stop. And yet the edge itself still lies beyond, and it is not dark. This is the strange promise we have been circling all night, and we are nearly close enough to keep it. From beyond the dark ages, from the very beginning of the journey, one light still comes. It is older than the first star. It set out before any galaxy existed, when the whole universe was young and hot and shining everywhere at once, and it has been traveling ever since, stretching as it came. No ordinary telescope can see it, because after nearly 14 billion years of stretching, its waves are no longer light in any familiar sense. They have grown past red, past infrared, all the way down into the microwave band, the region of broad, slow waves millimeters across. The first light of the universe is still arriving, everywhere, all the time, disguised as a faint microwave hiss coming evenly from every direction in the sky. Think once more of the pond, one last time before we go and stand at its far shore. The stone fell long ago. The tight, bright rings near the splash are the young universe, crisp and vivid, and they exist now only in the past. What reaches the distant shore of the pond, after the long crossing, are waves grown so broad and so gentle that the water barely seems to move. A casual glance sees nothing at all. But the wave is there, still carrying the shape of the original splash, still holding the record of how the stone struck, faithful after the whole width of the pond. All that is needed is an instrument sensitive enough and a reader patient enough, and the far shore can reconstruct the splash it never witnessed. We are the far shore. The instruments have been built and the reading has been done, and what was found at the bottom of the long wavelengths is the subject of the next part of our journey. It is the oldest light in existence, the wall of ancient light that stands at the edge of everything we can see, wrapped around our bubble like the inside of an eggshell. It has a temperature and a texture, and a story written into it in patterns almost too faint to measure. Finding it was one of the quietest and most important accidents in the history of astronomy. Understanding it gave us the age of the universe. And its continued arrival, tonight, through the dark above your roof, is the closest thing the cosmos offers to a message from the beginning of time. We will meet it properly now, slowly, with no need to hurry toward anything. At the very limit of the observable universe, in every direction we can face, there is light. This is the fact the whole night has been traveling toward, and it deserves to be said simply. The edge of everything we can see is not blackness. It is a continuous, unbroken glow, arriving from all sides at once, older than every star and every galaxy, older than anything else that can be seen or ever will be. Astronomers call it the cosmic microwave background, a careful name for an almost impossible thing. It is the first light that ever traveled freely through space, released when the universe was young and hot and dense everywhere, and it has been in flight ever since. When we look at it, we are looking at the deepest past that light can show us. Behind it, no telescope can ever see. To understand where it came from, drift back with me to the universe's first age. In the beginning, everything we can now see was compressed into a space unimaginably smaller than it fills today, and it was hot, hotter than the center of any star. Matter as we know it could not hold together. There were no atoms, only a dense, glowing fog of loose particles, and light was trapped inside that fog like a lantern in thick cloud. Every ray of light, the instant it set out, collided with the crowded particles around it and was scattered in a new direction, over and over, endlessly. Light existed, everywhere, in enormous quantities, but it could not travel. The whole universe was luminous and blind at the same time, a sea of brilliance in which nothing could be seen, because no beam could hold a straight course for more than a moment. Then the universe did what it has done ever since. It expanded, and by expanding, it cooled. For a few 100,000 years, the fog thinned by slow degrees, the collisions gentler, the crowding relieved, until the temperature fell to a threshold written into the nature of matter itself. The fog condensed, in a sense, everywhere at once. And the moment the fog cleared, the light that had been trapped inside it since the beginning was free. Every beam simply continued in whatever direction it was traveling at that instant, and this time, nothing stopped it. The universe became transparent in a single cosmic moment, and its stored light poured outward in every direction from every point, a whole cosmos releasing its glow at once. That released light is what stands at the edge of our bubble tonight. When we look at the cosmic microwave background, we are seeing the moment the fog cleared, the instant the universe first became something that could be seen. Astronomers sometimes call it the surface of last scattering, the final place where light bounced before beginning its long, uninterrupted journey. It is the farthest and oldest thing visible from Earth, or from anywhere. And it explains, at last, why the edge of the observable universe glows in every direction. The clearing happened everywhere, so its light comes from everywhere. Whichever way we face, we look back toward that same moment, and the moment answers from all sides, a sphere of first light wrapped around every observer in the cosmos. When that light set out, it was not faint and it was not gentle. The young universe glowed with the brightness and color of the surface of a star, an orange-white brilliance filling all of space. If your eyes could have survived there, you would have seen light in every direction, a sky made entirely of glow. But nearly 14 billion years of expansion stand between that moment and this one, and expansion, as we have seen, stretches light. The waves of that first brilliance have been lengthened roughly 1,000-fold on their journey. What departed as the light of a glowing sky arrives as microwaves, broad and slow, far beyond anything an eye can catch. Its temperature tells the same story. The glow began at thousands of degrees, and it arrives tonight cooled to just under 3 degrees above absolute zero, a few degrees shy of the coldest cold that can exist. The first light of the universe still fills the sky, but it has grown so old and so stretched that the sky can wear it invisibly, a warmth of almost nothing, everywhere, forever falling. It is worth pausing on how strange and how gentle its discovery was. The background light was found by accident, by radio engineers troubleshooting a persistent hiss in a sensitive antenna. The hiss came from every direction equally, day and night, in every season. It could not be traced to any city, any storm, any single source in the sky, and no adjustment would remove it. The engineers cleaned the instrument and questioned every part of it, and the hiss remained, faint and steady and universal. Only slowly did it become clear what they had stumbled into. The noise was the universe. The oldest light in existence, predicted but never yet observed, was arriving in their antenna as a soft microwave murmur from everywhere at once. There is an old, homely detail worth keeping here. An ordinary television of the old kind, tuned between stations, filled its screen with flickering static, and a small fraction of that static was this same first light, caught by accident in a living room. The beginning of the universe has been quietly present in the background of ordinary evenings all along. The abundance of this ancient light is worth pausing over, because it is not a rare or delicate thing hiding in some corner of the sky. It is the most common light in the universe, by an enormous margin. For every particle of matter that exists, there are on the order of 1 billion particles of this first light, still traveling, still filling space. In every cubic centimeter of the universe, in the emptiest void and in the room where you are resting, there are about 400 of these ancient light particles passing through at this moment, relics of the first clearing, going about their long journeys. Hold up your hand, and the first light of the universe is passing through it now, a silent traffic almost 14 billion years old, too gentle to feel, too stretched to see, and never absent from anywhere. The ancient light even records our own motion. Because we are moving through the universe, carried by the drift of our galaxy at hundreds of kilometers every second, the glow ahead of us is compressed very slightly warmer, and the glow behind us stretched very slightly cooler. And from that faint difference, astronomers have read the true velocity of our galaxy through the cosmos, measured against the oldest reference frame there is. The first light is not only a picture of the beginning, it is the stillest water the universe offers, and our wake through it is visible. The background glow turned out to be almost perfectly smooth, the same temperature everywhere to an astonishing precision, and that smoothness itself tells us the young universe was calm and nearly uniform, the same in every direction. But almost perfectly is not perfectly, and the difference is where everything interesting lives. Mapped carefully across the whole sky, the ancient light carries tiny variations in temperature, differences of only about 1 part in 100,000. The maps of these variations are usually drawn in false color, mottled blue and gold, and it matters to remember that the colors are only a way of seeing. What they record are places where the newborn universe was very slightly denser and places where it was very slightly thinner, small unevennesses in the fog at the moment it cleared. Those faint mottles are the most important texture in existence because they are the seeds of everything. Where the young universe was a little denser, gravity had a head start. The slightly thicker regions pulled in matter from their thinner surroundings, growing denser still, gathering gas across millions and then billions of years, until the gathered material lit its first stars and assembled its first galaxies. Where the universe was a little thinner, matter drained away toward the denser regions, leaving the great empty spaces that separate the galaxy clusters today. Every structure we have met tonight, every galaxy in every deep photograph, the clusters and the filaments and our own Milky Way, and the sun, and the small world where you are resting, all of it descends from those faint patches in the wall of ancient light. The pattern at the edge of the observable universe is the seed pattern of everything inside it. The universe was never perfectly uniform, and that tiny unevenness is why anything exists at all. There is one more gift written into the ancient light, and it may be the greatest. The background glow carries, in its temperature and its stretching and the size of its mottled patches, a record of the conditions that made it, and from that record, the age of the universe can be read. The answer comes out clean and confident. The first light has been traveling for about 13.8 billion years. The universe, from its beginning to this night, is 13.8 billion years old. That number, drawn from the oldest light there is one of the most carefully measured facts in all of science, and it sets the stage for the strangest turn in tonight's whole journey. Because now we hold two numbers side by side, and they do not seem to fit. The light at the edge of our bubble is 13.8 billion years old. It has traveled at the fastest speed the universe allows for 13.8 billion years. And yet the edge it comes from now lies 46.5 billion light-years away. Sit with that for a moment, gently. If nothing outruns light, and the light traveled for less than 14 billion years, how did its source come to rest more than 3 times that distance from us? The numbers seem to accuse each other. One of them looks like it must be wrong. Neither of them is, and the resolution, waiting just ahead, is the key to the entire strange machinery of the edge of the universe. We can take our time getting there. The old light is patient, and so is the night. Let us gather, for a moment, everything the night has given us so far, and stack it gently in one place. We began with the darkness between the stars, and found that it is not darkness at all, but stretched light our eyes cannot catch, and that the dark sky itself is evidence that the universe had a beginning. We measured the bubble we live in, the observable universe, a sphere of seeing 46.5 billion light-years in radius, centered on you, as an identical sphere is centered on every observer everywhere. We learned that looking outward is looking backward, that every image in the sky is a delivery from the past, and that the deepest possible view arrives at the earliest possible time. We followed light down the long wavelengths, watching it stretch as space expands, out of the visible colors, through the infrared, into the microwave country beneath. And there, at the very rim of the bubble, we found the wall of ancient light, the cosmic microwave background, the freed glow of the universe's first clearing, still arriving after 13.8 billion years, carrying the seeds of every galaxy in its faint mottled pattern. That is where we stand tonight. If you have drifted in and out along the way, nothing is lost. The journey so far folds into a single sentence. The edge of what we can see is the beginning of time, glowing in every direction, and the whole visible universe is inside it. Now we can face the two numbers squarely, because everything needed to resolve them is in hand. Number 1. The age. The light of the cosmic microwave background has been traveling for 13.8 billion years, moving the entire time at the fastest speed the universe permits. Number 2. The distance. The matter that released that light, the fog that cleared at the beginning, is now about 46.5 billion light-years away from us. On their face, these numbers cannot both be true. A traveler, moving at light speed for 13.8 billion years, should stand 13.8 billion light-years from home, no more. And yet the source of the oldest light stands more than 3 times farther away than that. It looks at first like a contradiction at the heart of cosmology, as if someone has misplaced more than 30 billion light-years. The resolution is simple to say, and it changes everything. The distance was not fixed while the light was in flight. The road itself was growing. Every ordinary journey assumes a stable road. When you walk a mile, the mile holds still beneath you, and at the end of it, you are 1 mile from where you began. Light crossing the universe enjoys no such courtesy. It moves through space at its constant, unbreakable speed, never slowing, never straying, but the space it moves through is expanding the whole time. The stretch of road the light has already covered keeps growing behind it, quietly adding distance between the traveler and home long after the traveler has passed. And the road still ahead grows too, the destination drawing away even as the light approaches. The journey is honest, but the map is alive. By the time the ancient light arrives at our instruments, the place it came from has been carried far, far beyond the distance the light itself actually traveled, because for nearly 14 billion years, every part of the road between here and there has been lengthening without pause. The numbers become almost tender when you see where the journey began. When the fog cleared and the first light was set free, the matter that would one day become our galaxy, our sun, and you, was not distant from the matter that released the light we now receive. The two regions were close, by cosmic standards, only about 40 million light-years apart, nearer than many galaxies we consider neighbors today. The light set out across that modest gap, and the gap began to grow beneath it. Every year of travel, expansion added new distance, both behind and ahead. What began as a 40 million light-year crossing became 100 million, a billion, 10 billion, the destination receding, the origin receding, the light pressing on at its fixed speed through a space that would not hold still. 13.8 billion years later, the light finally arrives and looks back, in a manner of speaking, to find its birthplace, now 46.5 billion light-years away. Nothing in the story ever moved faster than light through space. The space between simply grew and kept growing, and space is allowed to do that. It has been doing it since the beginning of time. Here, then, is the clean shape of the resolution, small enough to keep beside you as you drift. Light moves at a fixed speed through space. Space itself is free to grow, without limit, and its growth is not travel and breaks no law. Both facts are true at once, everywhere, always. And the edge of the observable universe is simply the place where those two facts meet, the balance point between how long light has had to travel and how much the universe has stretched beneath it while it did. The bubble is 46.5 billion light-years in radius, rather than 13.8, because the universe has never once stopped growing while the oldest light was on its way. There is no contradiction. There is only a road that lengthens under every traveler, and a traveler that never tires, and the long patience of both. It is worth being precise, in a soft way, about what it means to say that space expands, because the phrase invites misunderstandings that make the universe seem stranger than it is, and it is quite strange enough already. Expansion does not mean that galaxies are flying apart through space, like debris from some detonation, racing across a fixed and waiting emptiness. Expansion means the distances themselves are increasing. Space is not a stage that things move across. It is more like a fabric in which everything is embedded, and the fabric is being gently enlarged everywhere at once. A galaxy on the far side of the universe is not rushing away from us in any local sense. It floats almost at rest in its own neighborhood, going about its slow business, while the amount of space between its neighborhood and ours quietly multiplies. Both galaxies can be nearly motionless, and still the gap between them widens, because the widening belongs to the gap itself, not to anything's motion through it. The classic picture, worn smooth by generations of explanation, is rising bread. Imagine a loaf of raisin bread in the oven, the dough studded with raisins, and imagine the dough rising evenly everywhere. No raisin swims through the dough. Each one rests exactly where it always was, embedded in its own spot. And yet every raisin moves away from every other raisin, because the dough between them is growing. From the point of view of any single raisin, all the other raisins are receding, and the farther ones recede faster, because there is more rising dough between them, doing more total rising. No raisin is the center of the loaf's expansion. Every raisin sees itself as the still point of a retreating world, and every raisin is equally right and equally wrong. Swap the dough for space, and the raisins for galaxies, and you are holding the true picture of the expanding universe, warm and unthreatening, which seems a fitting shape for it at this hour. The loaf invites one last question, and it deserves a gentle answer before we move on, because nearly everyone asks it. If space is expanding, what is it expanding into? The loaf, after all, rises into the oven around it. The honest answer, explored at greater length on an earlier evening here on the channel, is that the universe does not need an oven. The expansion is not a swelling of the universe into some larger surrounding emptiness, because the universe is not an object with an outside. It is everything, including all the space there is, and its expansion is simply the growth of the distances within it. No edge advances into new territory. No frontier eats up surrounding nothingness. Every point moves away from every other point, and that is the whole event, complete in itself, requiring no room beyond itself. Analogies falter here precisely because every loaf we have ever baked sat in a kitchen, and the universe does not sit anywhere. It is the kitchen and the loaf and the rising all at once. If the question still itches a little, let it. Some questions are shaped by the habits of creatures who live inside rooms, and the universe is under no obligation to fit them. It expands into nothing because it needs nothing to expand into, and it has managed this trick gracefully for 13.8 billion years. Notice what that picture quietly implies, because it is the doorway to the next part of our journey. The farther apart two raisins sit, the faster the rising dough carries them from one another. There is no limit written into that relationship. Take 2 points far enough apart, and the growth of all the dough between them can carry them apart faster than any raisin could ever roll through the dough itself. In the universe, the same arithmetic holds. Distant galaxies recede faster than near ones, and the relationship keeps climbing with distance, past every ordinary speed, up toward and beyond the speed of light itself. That sounds like it should be forbidden. It sounds like the one rule the universe never breaks, being broken as a matter of routine, everywhere, on the largest scales there are. It is not broken. But the explanation deserves its own unhurried telling, and before we reach the galaxies that outrun light, we should first hear how humanity discovered any of this at all. It is a story of stubborn equations, mistaken certainties, a patched theory, and a sky full of smudges that turned out to be other worlds of stars. That story is where we drift next, with no need to hold on to anything we have learned tonight. It will all be waiting for us, further along, exactly where we left it. The expanding universe was not a guess, and it was not a welcome discovery. It was found reluctantly, over decades, against the grain of what nearly everyone believed, and the story of how it was found is one of the quiet epics of human thought. It begins with a theory of gravity, the deepest ever devised, one that described gravity not as a force reaching across space, but as the bending of space and time themselves. Matter curves the space around it, and things move along those curves, and from that single idea flowed predictions of extraordinary precision about the orbits of planets, the bending of starlight, the slowing of time near heavy bodies. The theory set the ground rules for how the universe works, and it has passed every test put to it in the century since. But when its own author turned it loose on the universe as a whole, it said something he could not accept. It said the universe could not stand still. At the time, standing still was precisely what everyone believed the universe did. The cosmos of that era was thought to be a single grand system of stars, eternal and unchanging, a fixed and permanent sea of lights that had always been and would always be. But the equations kept insisting otherwise. A universe filled with matter, they said, cannot hold its shape because gravity never stops pulling. Left to itself, everything drifts toward everything, slowly at first, then faster, until the whole arrangement folds in on itself. A static universe was a pencil balanced on its point. The theory demanded a universe in motion, either growing or shrinking, and its author, trusting the stillness of the night sky over the restlessness of his own mathematics, chose to silence it. He inserted an extra term into the equations, a patch, a small adjustable number representing a gentle repulsion built into empty space itself. Tuned precisely, this new outward push balanced gravity's inward pull, and the universe of the equations stood still, as everyone knew it should. He would later call it the greatest blunder of his life. Keep the patch in mind, though. It sleeps for a while in this story, and then it wakes, and when it wakes it will turn out to be one of the truest things he ever wrote. While the theorists argued with their equations, the observers were struggling with smudges. Scattered among the crisp stars of the night sky, telescopes had long revealed faint, cloudy patches of light, little glowing wisps that would not resolve into points. The prevailing assumption held that they were nebulae, clouds of gas and dust drifting among the stars of our own system, minor furniture in the one great galaxy that was thought to be the entire universe. The largest and brightest of these smudges was a favorite target, a soft spindle of light visible even without a telescope on a dark night. To settle what it was, someone needed its distance, and distance is the hardest thing in astronomy. A dim light near at hand and a brilliant light far away look identical from the middle of the sea. The key that finally unlocked the distances was a special kind of star, and it deserves a gentle telling of its own. Among the variable stars, the ones that brighten and dim in cycles, there is a family with a remarkable property. These stars pulse, swelling and contracting in a steady rhythm, and the tempo of the pulse is tied directly to the star's true brightness. The slower the star's rhythm, the more luminous it truly is. That relationship is a gift of almost unreasonable generosity, because it turns a rhythm into a distance. Find such a star anywhere in the sky, time its slow breathing over weeks and months, and the rhythm tells you how bright the star actually is. Compare that true brightness with how faint the star appears in your telescope, and the gap between the two tells you exactly how far its light has traveled. Astronomers had found a way to read distance off the face of a star, and it reached far beyond every older method. Then someone found one of those pulsing stars inside the great smudge. Its rhythm was measured, night after patient night, and the rhythm gave its true brightness, and its true brightness, set against its extraordinary faintness, gave a distance. The distance was devastating, in the quietest way. The pulsing star, and therefore the smudge that held it, lay far beyond the edge of our own galaxy, not among our stars at all, but immensely farther, so remote that it could only be an entire separate system of stars, an island of hundreds of billions of suns adrift in its own part of space. The smudge was a galaxy. The little glowing wisps scattered across the sky were galaxies, all of them, thousands upon thousands of separate stellar cities receding into the depths, and the universe was no longer one system of stars, but a sea of them. The night sky acquired its true architecture in a single generation, and it has never looked small since. The second discovery followed close behind, and it is the one that set the sky growing. The light of those newly recognized galaxies held one more secret. Light, remember, is a wave, and the spacing of its waves can be read with great precision because every chemical element leaves a signature in light, a pattern of lines at exact known wavelengths, as individual as a fingerprint. When astronomers examined the light of galaxy after galaxy, the fingerprints were all there, unmistakable, but they were displaced. In almost every galaxy measured, the entire pattern sat shifted toward the red, toward longer waves, as if every fingerprint had been gently stretched before delivery. And the fainter and more distant the galaxy, the greater the stretching. The nearby galaxies showed a slight reddening. The remote ones showed reddening so pronounced that their light had clearly been lengthened enormously somewhere on its journey. It is worth appreciating how slow and unglamorous this work was, because the universe rarely announces itself. The measurements were gathered one galaxy at a time, over years, on long, cold nights at mountaintop telescopes, each spectrum coaxed from hours of patient exposure onto glass plates, each shift measured by hand against laboratory references. No single night's work proved anything. The truth assembled itself gradually, plate by plate, galaxy by galaxy, the way a shoreline emerges from fog, until the pattern could no longer be doubted by anyone who looked at the accumulated whole. The people doing the measuring did not always understand what they were measuring, and some resisted the conclusion for years, which is its own kind of reassurance. The expanding universe was not an idea anyone wanted. It was an idea the light insisted on, patiently, in observatory after observatory, until the human mind gave way before the evidence. Science at its best moves like the night sky itself, slowly, quietly, and without any need for our agreement. There is a homely experience that carries the essence of this, and you have almost certainly lived it. Stand on a street corner as an ambulance passes and listen to the siren. As the vehicle approaches, Each pulse of sound is emitted a little closer to you than the one before, so the waves arrive compressed and the pitch sounds high. The moment it passes and begins to recede, each pulse is emitted a little farther away, the waves arrive stretched, and the pitch drops. Nothing about the siren changes. The stretching and squeezing happen in transit, and they happen because the distance between you and the source is changing. Sound carries its motion in its pitch. Light does exactly the same, carrying approach as a shift toward blue and retreat as a shift toward red. Read the shift, and you have read the motion. Read across the whole sky. The message was single and overwhelming. Nearly every galaxy in the universe is receding from us, and the recession follows a law of serene simplicity. The farther away a galaxy sits, the faster it retreats, in direct proportion. Double the distance, and you double the speed of retreat. 10 times the distance, 10 times the speed. There is only one kind of universe that behaves that way, and we met it in the last part of our journey, warm from the oven. It is the rising loaf. A universe in which space itself is growing produces exactly that pattern, every galaxy receding from every other, with speed proportional to separation, and no galaxy anywhere doing any of the moving. The galaxies are not fleeing us. Ours is not fleeing them. The distances themselves are increasing, everywhere, evenly, and they have been since the beginning. And one refinement completes the picture, worth a single soft beat. For the truly distant galaxies, the reddening is not really the ambulance effect at all. The galaxies barely move through space. Their light is stretched because the space it crossed was stretching while it traveled. The wave grows because the road grows. The redshift of the deep universe is not the sound of things rushing away. It is the signature of the road itself, lengthening beneath the light, which is why, at great enough distances, the retreat can exceed the speed of light without anything ever outrunning a light beam where it lives. The static universe was gone, and its author's patched equations were vindicated in the strangest possible way. Strip away the patch, let the equations speak, and they describe exactly what the telescopes now saw, a universe in headlong growth. For a while, the story seemed complete, and the patch seemed like a historical footnote, an odd, repulsive term invented to prop up a universe that never existed. But the universe was saving its best turn for last. Generations later, astronomers set out to measure how much the expansion was slowing down, as common sense said it must, with all that gravity pulling inward against the growth. They used exploding stars of a precisely known brightness as distance markers, lighthouses visible across billions of light-years, and they compared distance against redshift, far into the deep universe. The expansion was not slowing. It was speeding up. The universe has been growing faster and faster for billions of years, and something must be driving that acceleration, some influence woven into space itself, pushing outward everywhere at once. The patch had awakened. A gentle repulsion belonging to empty space, the very thing once invented in error and abandoned in embarrassment, is real, and it has a modern name. We call it dark energy, and it is quietly in charge of the universe. What it is doing to the edge of everything we can see, and to everything we can never reach, is where our journey drifts next. Dark energy is a modest name for the largest single ingredient of the universe, and it earns a slow, careful look before we return to the edge. The name records our honesty more than our knowledge. Energy, because it does work on the cosmos, driving the expansion faster. Dark, because it emits no light and reveals itself only through what it does. Beyond that, its nature remains one of the great open questions in science, and tonight we can hold that openness comfortably as a thing the universe has not yet told us, rather than a thing anyone is hiding. What we do know is its character, and its character is simple, patient, and strange. Dark energy behaves as a property of space itself, a faint outward pressure that belongs to the vacuum, present everywhere, in every cubic meter of emptiness, the same yesterday, today, and for billions of years past. The consequences of that one sentence unfold with a quiet, compounding logic. If the push belongs to space, then more space means more push. Take two clusters of galaxies drifting apart. The stretch of emptiness between them carries the outward pressure, so the gap widens. But the widening creates new space, and the new space carries the same pressure, so the total push between the two clusters is now greater than before, so the gap widens faster, which creates space faster still. The process feeds itself, gently but without pause. This is why the expansion of the universe is accelerating. Matter thins out as the universe grows, its gravity weakening with every passing age, but dark energy does not thin because it is not a substance scattered through space. It is a property of space, and space is the one thing expansion always makes more of. In the long accounting of the cosmos, roughly 7 parts in 10 of all the energy there is behaves this way, and its share grows with every year that passes. The universe is mostly made of its own quiet insistence on growing. You might wonder, hearing this, whether the same push is at work closer to home, whether the room around you is stretching, whether your own body, the Earth, the orbit of the Moon, are all slowly being pried apart by the space within them. The answer is a firm and comforting no, and it deserves to be said clearly. Expansion only wins where distances are enormous and matter is thin. Anywhere matter has gathered, gravity rules without challenge. Your body is held by chemical bonds gravity has no say in, and the push of the vacuum within you is so unimaginably small that it will never, in the entire history of the universe, matter. The Earth holds its shape. The Moon holds its orbit, and the Sun holds its planets, and the galaxy holds its hundreds of billions of stars, all of them bound systems, knots pulled tight long ago, far too tight for the gentle pressure of empty space to loosen. Even entire clusters of galaxies hold together, their mutual gravity comfortably stronger than the push across the mere millions of light-years between members. Expansion lives only in the deep gaps between the clusters, the enormous empty reaches where matter is sparse, and gravity's grip has faded to almost nothing. There, and only there, space wins. Nothing in your room is expanding. Nothing in your sky is expanding. The stretching of the universe happens far beyond the last landmark anyone could ever walk to, out in the emptiness between the great cities of stars. And out in that emptiness, the arithmetic we met in the rising loaf begins to climb toward its strange conclusion. The rule of expansion is proportional. Every stretch of distance grows by the same small fraction each year, so the more distance between you and something, the more new distance appears between you and it each year. Recession speed stacks with distance, steadily, relentlessly, without any ceiling written into the rule. A galaxy 100 million light-years away drifts back at a certain stately pace. A galaxy a billion light-years away recedes 10 times faster. Carry the proportion outward, gap after gap, and simple arithmetic delivers you to a threshold. At some particular distance, the recession reaches the speed of light itself. And beyond that distance, it exceeds it. Galaxies past that line are being carried away from us faster than light travels. This is not a rare technicality affecting a few remote objects. Most of the galaxies in our observable universe, the clear majority of everything we can see, lie beyond that line tonight, receding faster than any light beam could ever fly. The line itself has been measured, and its position is worth knowing because it is closer than you might guess. The distance at which the expansion carries things away at exactly the speed of light lies about 14.5 billion light-years from us, in every direction, a sphere far smaller than the full bubble of seeing. Everything beyond that sphere, tonight, is receding faster than light, and the deep photographs are full of such places. It is a boundary with a strange, softened character, though, and this is where the universe shows a subtlety that rewards a slow mind. Being beyond the light speed line does not by itself seal a galaxy away from us. Light from just beyond the line can still, in time, arrive, in the way we are about to see, because the line's position shifts as the universe's expansion history unfolds, and a patient photon can find itself overtaken by better conditions. The line where recession passes light speed is not a wall but a watermark, a reading of the current strength at one distance, at one era. The true point of no return, the distance beyond which nothing can ever reach us, and nothing of ours can ever arrive, lies elsewhere, and we will draw that darker, quieter line in the next part of the journey. For now, hold only this. The universe is arranged in currents, gentle near home, stronger with every gap crossed, and somewhere out there the current outruns light itself, and the galaxies ride it away from us, unhurried and serene, losing nothing by the going. Here it is natural to object, because tonight we have leaned more than once on the firmest rule in physics. Nothing moves faster than light. The rule is real, and it remains unbroken, and the resolution is one of the most beautiful distinctions in all of science. The rule governs motion through space. It says that nothing may overtake a light beam in its own neighborhood, that no object, no signal, no message may race through space faster than light does. The distant galaxies obey completely. Each one rests almost motionless in its own local space, drifting at ordinary speeds among its neighbors, overtaking nothing. What exceeds the speed of light is not the galaxy but the growth of the distance, the swelling of the road between us, and the road is not a thing moving through space. The road is space. Expansion is not travel. It has no speedometer, breaks no limit, and outruns light without ever moving at all. Space, as the reference put it well, plays by its own rules, and its rule is that there is no rule on how fast distance itself may grow. If a galaxy is receding faster than light, you might expect it to be invisible, its light hopelessly outpaced, like a swimmer carried backward faster than they can swim. And yet we see such galaxies every night, thousands of them, filling the deep photographs. The explanation is a small marvel of patience. The light we receive from them tonight did not fight today's distance. It left long ago, when those galaxies were far closer and the crossing was gentler. And even light that found itself in trouble could, in the past, be rescued. Picture a photon launched toward us from a galaxy already receding quickly. In its early years, the stretch of road it occupied was growing so fast that the photon, though flying at full speed forever forward, was actually losing ground, carried backward like that swimmer over a widening river. It never stopped swimming. It never slowed. For billions of years it made headway against the current, the only way light can, 1 light-year per year, while the current beneath it shifted as the universe aged and the expansion's local pace at its position eased. Slowly, the photon's stubbornness told. It crossed into waters where the current was weaker, gained real ground at last, and after an almost unthinkable journey, it arrived, stretched and reddened and ancient, in a telescope on a small blue world. Some of the light in our night sky spent most of the age of the universe holding its ground and no more. Its arrival is not just information. It is endurance, written in a wavelength. But notice what the acceleration does to that story, going forward. The rescue depended on the current easing, and for most of cosmic history, it did ease. Matter's gravity dragged on the expansion, gentling it age by age, opening the door for determined light to get through. Dark energy has closed that era. The expansion now quickens instead of calming, and the door is swinging the other way. Light launched toward us today from far enough out will find the current against it growing forever stronger, and no amount of endurance will save it. It will swim at full speed, forever, and forever lose ground and never arrive. Which means there is a distance, tonight, beyond which the universe has already fallen silent for us. Not invisible yet, because old light is still arriving and will keep arriving for ages. But silent, in the sense that nothing happening there now, no light, no signal, no cry, can ever reach us, no matter how long the universe runs. The edge of what we can see, it turns out, is not the only edge drawn around us. There is another, closer and stranger, and far more final, the edge of what we can ever touch. And that second edge, the true frontier of everything we could ever know or reach, is where the night takes us next, slowly, with nothing required of you but rest. There are two edges drawn around us tonight, and the difference between them is one of the quietest and most consequential facts in cosmology. The first edge we know well by now. It is the edge of seeing, the rim of the observable universe, the sphere 46.5 billion light-years away, where the wall of ancient light stands. That edge marks how far into the past our view can reach, and in its own patient way, it is generous. It creeps outward all the time. With every passing year, light from slightly more distant regions completes its long journey and arrives for the first time, and the sphere of everything humanity has ever seen grows a little. Left alone, seeing only improves. The visible universe is a gift that keeps unwrapping itself, year after year, era after era, for as long as anyone cares to watch. The second edge is different, and we met its shadow at the end of the last part. It is the edge of reaching, the boundary of what we could ever touch, signal, or visit, even in principle, even with unlimited time and light-speed messengers. In a universe whose expansion is accelerating, that edge is far closer than the edge of seeing, and unlike the edge of seeing, it does not grow. It closes in. Any galaxy beyond a certain present distance, around 16 to 17 billion light-years from here, is already receding so quickly and will only recede faster that nothing sent from Earth tonight could ever arrive there. A light beam launched toward such a galaxy would swim forever against a current that only strengthens, gaining on its target not at all, losing ground for eternity. And the silence runs both ways. Nothing that happens in those galaxies tonight, no light, no signal of any kind, can ever again affect us. We are, from this night onward, causally separated, two regions of the same universe that can no longer touch, like ships that have drifted out of every possible hailing range on a sea that widens faster than any voice can cross. Now set the two edges side by side and let the sizes settle in. The sphere of seeing reaches 46.5 billion light-years. The sphere of reaching extends only about a third as far. Everything between the two, every galaxy past 17 billion light-years but within sight, is visible and untouchable at once. And that in-between region is not a thin border strip. It is almost everything. Of all the galaxies in our observable universe tonight, roughly 19 out of every 20 already lie beyond the edge of reaching. We can see them. We can study them, admire them, and map them. Their old light arrives faithfully and will keep arriving for enormous ages. But they have, in every practical sense, already left. No message could reach them. No journey could end there. The universe we can look at and the universe we could ever belong to are two very different sizes, and the second is a small fraction of the first. There is an earlier evening here on the channel that walked this territory slowly, asking how much of the universe we can never reach, and tonight we need only its gentlest conclusion. The unreachable universe is not being torn from us in any way we could feel or witness. Nothing lurches. Nothing vanishes. The line between reachable and unreachable is silent and invisible, and galaxies cross it constantly, without ceremony, the way a ship crosses the horizon at sea without the slightest shudder. Somewhere out there tonight, a galaxy of several 100 billion stars is drifting across our event horizon, passing from the world we could in principle touch into the world we never can, and no instrument anywhere registers the crossing. The universe does not mark the moment. The lights stay on. The old light keeps arriving. Only the possibility has quietly changed, the way possibilities do, without sound. If you wanted to feel the finality of that line, you could imagine trying to beat it. Suppose some far future civilization, endlessly patient and endlessly capable, set out tonight to chase a galaxy that has just crossed the edge of reaching. Their craft leaves at the fastest speed physics allows, a whisker below the speed of light, and it never slows, never turns, never stops. It would not be enough. The distance to that galaxy is growing faster than the craft can close it, and the growth itself is accelerating, so every year of the chase ends with the goal farther away than the year began. The pursuit is not difficult. It is impossible, in the strict sense that the universe's own geometry forbids it, and no cleverness, no engineering, no stubbornness can amend the geometry. The travelers could fly for 1 trillion years and arrive nowhere, their destination receding beyond them faster than their own light could follow. There is something almost restful in a limit that absolute. It closes the question completely. The galaxies beyond the horizon are not waiting for us to try harder. They are simply elsewhere now, in the fullest meaning the word has ever had, and the kindest response to elsewhere, tonight as always, is to let it be. What happens to the image of a galaxy that has crossed over is one of the strangest gentle facts in all of astronomy. The galaxy does not blink out. We continue to see it because the light it emitted before the crossing is still en route, and that light keeps arriving for billions of years. But we are watching a supply that can no longer be replenished, the last shipment of an ended correspondence, and the manner in which it runs out is not sudden darkness. As the galaxy recedes ever faster, each successive wave of its light is stretched more than the one before, and the moments of its history arrive more and more slowly, spaced further and further apart. From our side, the galaxy's story appears to decelerate. Its image slows, reddens and dims, playing at an ever lazier tempo, like a film winding down, like a clock losing time. In the far future, its image will linger near the edge of detectability, frozen on one late moment of its history, fainter and redder and slower without end, never quite finishing, never quite gone, a photograph left out in the sun, fading but never fully blank. The galaxies do not leave us with a farewell. They leave us with a long, quiet afterimage, and the afterimage outlasts the acquaintance by billions of years. Follow this forward, patiently, across enormous stretches of time, and the future of the night sky comes into view. It is a dimming future, but a slow one beyond all human meaning, and it should be held the way we hold all such things tonight, at the enormous, restful distance where it truly lives. Over the coming hundreds of billions of years, the galaxies beyond our immediate neighborhood will cross the edge of reaching, one by one, and their after-images will stretch and fade past the sensitivity of any conceivable instrument. Our own neighborhood is exempt, bound too tightly for expansion to touch. The nearby galaxies, ours among them, are gravitationally tied and slowly falling together, and in the deep future they will merge into a single enormous system of stars, one last great city of light with all its lamps still burning. But beyond that merged galaxy, the sky will empty. The wall of ancient light will stretch until it too fades beyond detection, its waves grown longer than any antenna could catch. The deep universe will still exist, still hosting its trillions of galaxies, each one alone behind its own horizons. It will simply no longer be visible, from anywhere, by anyone. And here lies perhaps the most sobering thought of the whole night, made gentle by its distance. Imagine astronomers arising in that far era, on some world circling a late, slow star in the merged galaxy. They would be as clever as any who ever lived, with instruments as fine as physics allows. And when they looked up, they would find their galaxy, and then nothing. No other galaxies. No ancient glow at the edge of the sky. No red-shifted light announcing an expansion, because nothing visible would remain to be redshifted. Every line of evidence that led our era to the truth, the receding galaxies, the background light, the growing distances, will have erased itself. Their most careful science would conclude, reasonably and wrongly, that their galaxy floats alone in an infinite, static emptiness, that it is the whole of everything, and that it had no beginning worth speaking of. The truth will not have changed. The evidence will simply have left. The universe will keep its history the way deep water keeps a shipwreck, present but unreachable, and the last readers of the sky will live in a library whose books have all been recalled, which casts our own era in a light worth resting in for a moment. We happen to live in the universe's readable age. The galaxies are still visible in their trillions. The ancient light still arrives, still measurable, still carrying the seed pattern of everything. The expansion still writes itself plainly across the sky, distance by distance, redshift by redshift, for anyone who builds the instruments to read it. None of this was owed to us, and none of it is permanent. It is a long morning, hundreds of billions of years wide, and we are early in it, and everything the cosmos is willing to say about its own beginning is still being said, tonight, in old light falling on quiet antennas. The window is not closing in any sense that should trouble your sleep. It is simply open now, and we are awake inside it, and that is a fortune worth noticing on the way to rest. So the two horizons stand around us tonight, one of seeing and one of reaching, one growing and one closing, and between them lies almost everything we will ever look at. What remains now is the deepest question of all, the one the title of tonight's journey has been holding since the first minute. We have been to the edge of seeing and found the wall of ancient light. We have traced the edge of reaching and found the long silence beyond it. But what is the edge, really? Where did it come from? What would it mean to stand there? And what, if anything, lies on the other side? The answers gather around one final correction, the deepest of the night, to the picture most of us were given of how everything began. The beginning, it turns out, was not an explosion, and it did not happen somewhere. It happened everywhere, and that single fact, softly unfolded, explains the entire strange architecture we have wandered through tonight. It is the last stretch of the journey, and the gentlest, and it ends, as all good journeys do, at home. Most of us were handed the same picture of the beginning of the universe, somewhere along the way, and the picture is wrong in almost every detail that matters. It goes like this. Once, there was empty black space, and in the middle of it sat a tiny, impossibly dense egg of matter, everything that would ever exist, packed into a single point. Then, the egg detonated. Matter sprayed outward into the waiting darkness like debris from a grenade, and the fragments became galaxies, still flying apart today from the site of the blast. It is an easy picture to hold, which is why it survives, and it seems to follow from what we have learned. If everything is drifting apart, then running the film backward should gather everything into one place, one point, one center where it all began. Almost every piece of that picture is mistaken, and correcting it, gently, is the final key to the edge of the universe. The first correction is the deepest. The beginning was not an explosion in space. It was an expansion of space. In the grenade picture, space is a stage, already existing, dark and empty, waiting to receive the flying debris. In the true picture, there is no stage. Space itself is part of what began, and the beginning happened to all of it, everywhere, at once. Every point in the universe was inside the beginning. The place where you are lying tonight was inside it. The most distant galaxy ever photographed was inside it. The regions beyond our horizon that no one will ever see were inside it too. There is no crater, no center, no monument marking where it went off, because it did not go off anywhere. It went off everywhere, and everywhere has been growing ever since. The proof of this surrounds us, and we have already stood before it tonight. If the beginning had happened at one point in space, its afterglow would hang in one direction, a bright patch in an otherwise dark sky, and we could point to it and say, "There, that is where everything started." But that is not what the sky shows. The ancient light arrives evenly from every direction, a complete and seamless sphere of it, wrapped around us without a gap. We are surrounded by the afterglow of the beginning, and the only way to be surrounded by a beginning is to have been inside it. The wall of ancient light is not the light of a distant blast reaching us from one side. It is the glow of the entire early universe, seen from within, because within is the only place there is. Every observer in the cosmos, on every world, in every galaxy, is wrapped in the same sphere of first light, and every one of them is standing inside the same beginning, looking back at it from a different seat. Run the film backward properly, and the picture that emerges is not a gathering of debris toward a point. It is a shrinking of distances, everywhere, evenly, like an endless sheet being drawn tighter. The galaxies do not converge on one special location. They simply grow closer to their neighbors, all of them, everywhere at once, until galaxies merge into a continuous sea of stars, and the sea compresses into fog, and the fog into the glowing plasma we met at the wall, and further back still, into conditions of heat and density beyond anything the universe has known since. What we can say with confidence is that our entire observable universe, the whole 93 billion light-year sphere, was once compressed into a region smaller than an atom. What we cannot say is that the universe itself was ever a single point. If the universe is infinite now, then it was infinite then too, because an infinite thing can grow denser without having an edge, and every distance within it can shrink without the whole ever becoming small. The beginning may have been infinitely wide. It was simply, everywhere, unimaginably dense, and then, everywhere, it began to grow. And in its very first instant, by our best current understanding, the growth was of a different order entirely from anything since. The earliest moment of the expansion appears to have included a brief episode of stretching so rapid that the numbers stop cooperating with the mind. In a sliver of a second too small to say meaningfully aloud, a region the size of a grain of sand would have stretched toward the scale of a galaxy. Hold the reference material's image, because it is the right one. If the universe before that instant was a beach, an endless sandbox of such grains, then in that first moment, every grain on the beach inflated at once, each toward the size of a galaxy, all of them together, the whole beach at every point. Our entire observable universe, everything this night has wandered through, fits comfortably inside the descendant of a single grain. The rest of the beach is still out there, past every horizon, grain beyond inflated grain, farther than light will ever carry news. This early stretching quietly answers a puzzle the sky has been holding all night, in plain view. Consider the wall of ancient light on opposite sides of the sky. One patch stands 46.5 billion light-years to the north of you, so to speak, and the other the same distance to the south, and they are 93 billion light-years from each other. They have never been in contact in all the history of the visible universe. No light, no influence, no message could ever have crossed between them. And yet they match. Same temperature, to a part in 100,000. Same texture of faint mottling. They match the way two clocks match when they were set together before being carried apart. That is exactly what happened. Before the great stretching, those two regions were pressed close, sharing warmth, settling their differences, agreeing on a temperature. Then the first instant carried them out of each other's sight forever. The sky's far corners agree because they are old acquaintances, separated in infancy, wearing the same face on opposite sides of the universe. The edge of our view is stitched together by a closeness that ended before the first second was over. So now, at last, we can say what the edge of the universe really is, and every thread of the night draws together in the saying. The edge is not a wall, and it is not a place. Nothing sits there. Nothing would greet a traveler who arrived. If you could stand tonight in the region whose ancient light we receive at our horizon, you would find yourself in an ordinary sky, galaxies around you in every direction, a universe indistinguishable in character from our own, wrapped in its own sphere of first light. And on the rim of that sphere, glowing in one direction of that sky, would be a small patch of newborn universe whose matter, across 14 billion years, became our galaxy, our sun, and you. We are on their horizon as they are on ours. We are, tonight, someone else's edge of the universe, someone else's wall of ancient light, an early smudge in a stranger's deepest photograph. The edge is not where the universe ends. The edge is the past, seen from inside, and everyone is standing on everyone else's. Beyond it, in every direction, the universe continues. That much the geometry itself tells us. The overall shape of space can be measured using the ancient light as a ruler laid across the sky, and the method is lovely enough to deserve its own moment. Space, on the largest scales, could in principle be curved, the way the surface of the Earth is curved, and curvature changes geometry. On a curved surface, the angles of a large triangle refuse to add up the way schoolroom triangles do. Curve one way, and triangles grow fat, their angles summing to more than they should. Curve the other way, and triangles grow thin. Only in perfectly flat space do the angles come out exact. Now, the mottled patches in the wall of ancient light have a known physical size, set by how far a ripple could travel in the young universe before the fog cleared, and their distance is known too. Known size and known distance make the two far corners of an enormous triangle, with our instruments at the third corner, a triangle 46.5 billion light-years on a side, the largest geometry problem ever posed. If space were curved, the patches would appear larger or smaller than their true size warrants, magnified or shrunk by the bending of the light's long path. Astronomers measured with exquisite care, and the patches appear exactly the size flat geometry predicts. Every measurement returns the same answer. Space is flat, as far as precision can reach, with no detectable curvature at all. And flatness, whatever else it means the whole is enormously larger than the part we see, at the very least, many hundreds of times larger in extent, and quite possibly without any end at all. An infinite universe remains fully consistent with everything we observe. Past the wall of ancient light, there is every reason to expect more of the same, more galaxies, more clusters, more quiet, the same physics under the same kind of sky, going on and on, beyond our horizon, beyond the horizons of those beyond us, perhaps forever. The ocean does not end at the line drawn by the height of our eyes. It never did. And that, finally, is the strange and gentle truth the title of tonight's journey promised. Strange things do begin to happen at the edge of the universe, but the strangest is what the edge turns out to be. It is made of light, not darkness. It is a time, not a place. It recedes from every approach, is centered on every observer, and belongs to no one. It is the first morning of the universe, still arriving after 13.8 billion years, still falling silently through the dark above your roof tonight, through the trees, through the walls, through the quiet air of the room where you are resting. The universe does not end there. Only our seeing ends there, and our seeing was always the smallest part of what exists. Beyond every edge, more universe. Behind every darkness, more light. It has been that way from the first instant, and it will go on being that way, whether anyone watches or not. So we leave the edge where it has always been, wrapped gently around us, holding everything we will ever see. The wall of ancient light asks nothing of you. The galaxies crossing their silent horizons ask nothing of you. The endless universe beyond the last visible thing asks nothing of you at all. It is all simply there, enormous and calm, keeping its own time, at distances no worry can survive the trip across. Down here, at the center of your own universe, which is the only center there has ever been, the night is close and warm, and the old light falls without a sound. Let your breathing slow. Let the dark behind your eyes be soft. Sleep well, and good night.